This is section 5.3, double angle and half angle formulas. So what we're going to do is we're going to be deriving some of these formulas ourselves. A double angle formula for sine, which will be written something like sine of 2x. Double angle for cosine is cosine 2x, tan 2x, so on and so forth. But to derive the formula, we write sine of 2x as sine of x plus x, and then we'll use the addition formula from the previous section to simplify it. So if sine of 2x is sine of x plus x, then using the formula from the previous section, we have sine x cosine x plus sine x cosine x. And since those are the same, we add them together. We have a 2 in front. So sine of 2x is the same thing as 2 times sine of x cosine of x. Okay. Now for the double angle formula for cosine, we have several different options, okay? If you go directly, using the same method we did before, where we replace 2x with x plus x, and then use the addition formula from the previous section, we have cosine x minus sine x, which is cosine squared of x minus sine squared of x. Now, because we have cosine squared here and sine squared here, we can use a Pythagorean identity in one case where cosine squared is 1 minus sine squared x, and plug that into here, and then we can get a formula using only sines. Or we could also do the same thing using the Pythagorean identity and replacing sine squared instead of cosine squared to get one that's only in cosine. But basically we have 3 options here. They are all pretty easy to develop yourself, or you can memorize them, but you really do need to be familiar with these. Okay, now for the double angle formula for tangent. We have, again, a couple of options. The first option is to do what we did before and replace 2x with x plus x, then using the sum formula from the previous section, and we end up with 2 tangent x over 1 minus tangent squared of x. But you also have the opportunity to rewrite tangent of 2x as sine of 2x over cosine 2x. And then you can use the double angle formula for sine and then any of your double angle formulas for cosine to get it. Okay? So we have a lot of options here. And also, if we've been working a problem where we've already had to calculate the double angle for sine and the double angle for cosine, then we have the option of simply dividing them to get the double angle for tangent. Okay? So in summary, we have these formulas. We have 1 double angle formula for sine, 3 for cosine, and they are all equivalent, so it doesn't matter which is which. And then I've just chosen, well, this is the one we got directly from adding for using x plus x, and this is just one of the other 3 options for tangent of 2x. So this is the double angle for sine, and this is one of our double angles for cosine. Okay? So working a problem, using the given information to find the exact value of sine of 2x, cosine 2 theta, and tangent 2 theta. So we know that sine of theta is 3/5, and our theta is in quadrant 2. Okay? So if our angle is in quadrant 2, we have something like this. Our radius is going to be 5. This point is x, y, and y will be 3. So this is 3 here. This has got to be a negative number right here. And so this is a 3, 4, 5 right triangle, so that's negative 4/3. And that means this is our theta. We know our sine theta. Our cosine of theta is going to be negative 4/5. And tangent of theta is going to be negative 3/4. Okay, So for part A, we need to find sine of 2 theta. So that will be 2 times sine x times cosine x. 2 times 3/5 times -4/5. And that gives me -24 over 25. So -24/5 is sine of 2 theta. For B, I need to find cosine of 2 theta. And I can use any of these at all. I tend to remember this one best. That's the one I tend to go to, but any of them will work. So if I'm using this one, I need to do cosine squared. So -4/5 squared minus sine squared, 3/5 squared. So that is 16 over 25 minus 9 over 25, which gives me 7 over 25. So that's cosine of 2 theta. Okay. Now part C, we need to find tangent of 2 theta. I'm going to use this formula, and then I'm going to show you an alternate way. So tangent of 2 theta is 2 times the tangent of theta, which is -3/4, over 1 minus tangent squared, so -3/4 squared. Okay. So this is -3/2 divided by 1 minus 9 over 16. Okay. And I end up with -3/2 divided by, get a common denominator there, and subtracting, you get 7 over 16, which is -3/2 times 16 over 7, which ends up being -24 over 7. As an alternate, it's always sine divided by cosine. Which is -24 over 25 times 25 over 7. -24 over 7. So generally speaking, if I've already calculated sine and cosine of whatever world I'm in, if I'm later asked to find tangent of the same thing, it's usually easier just to do the division rather than to go to the formula, but the formula also works. Okay, so let's do cosine of theta is -5 over 13, and my angle is in quadrant 3. So I'm down here. That's theta. This is going to be 13. This is going to be -5, and so this is -5 here. This will be a -12. Using the Pythagorean theorem, it's a 5, 12, 13 triangle. So that's -12 right there. So I've got cosine of theta. My sine of theta is going to be -12/13. And tangent of theta is going to be -12 over -5, so 12 over 5. So for A, sine of 2 theta is 2 times sine times cosine. So 2 times -12 over 13 times -5 over 13, which ends up being positive 120 over 169. Now for B, cosine of 2 theta. I do cosine squared minus sine squared. So negative 5 over 13 squared minus negative 12 over 13 squared is 25 over 169 minus 144 over 169, which is negative 119 over 169. Okay? Now for part C, to find tangent of 2 theta. You can plug directly into here if you wish, but since I already have sine and cosine, I'm going to figure 120 over 169 divided by negative 119 over 169. So 120 over 169 times negative 169 over 119. And tangent will be 120 over 119.